Okay, so let's talk about degrees and radians. And I know people are usually more comfortable with degrees at the beginning, but radians are actually a lot easier to use. The math in using radians is a lot easier. So um, let's talk about this in terms of a circle, because radians actually come from the idea of a circle. Degrees, we're not really sure where they come from. A lot of people say maybe it has something to do with the rotation of the Earth because there's 360 degrees in a rotation, or things like that. But radians, we know exactly where they came from. They're based on the idea of a circle. So I'm just going to draw this on a coordinate plane just because it makes it easier for me. I like to draw them on a coordinate plane. So let's talk about a circle. So let's say that I walk all the way around a circle, right? So let's talk about the circumference of a circle. Does everybody know that the circumference of a circle is actually 2 pi r, right? 2 pi r. Hopefully everybody was screaming out, 2 pi r, 2 pi r. So circumference means the distance around the circle is 2 pi r, where r is the radius. All right, so if we have, now I want you to see how similar these kind of look for a second. So if we talk about a circle that has a radius 1, so, we're pretending that I drew this nice and even. So the radius anywhere I pick is 1. The circumference of this circle is going to be 2 pi times 1, which is obviously going to be 2 pi. So this distance around is going to be 2 pi. And this is where the idea of radians come from. Because what they did was they did something that was kind of clever. And they said, well, if the distance around is 2 pi, and that would be in whatever units you're using, so inches, feet, millimeters, whatever unit it is, right? That's a linear distance around here. It also happens to be, everybody knows, if I spin around here, angular distance, right? That spin around, so how much does my pen spin to get to there? Not how far has it traveled, but how much did it spin? We know that that's 360 degrees, because everybody knows there's 360 degrees in a circle, even if you don't know a lot about math, right? Say 360 degrees in the circle. So that's measuring two different things. It's measuring, this one measures how far my pen had to go to draw this circle, like how much I had to, if I were to lay this out, how long that string would be. And this one measures how much did I spin my pen to get there. So here would be 90 degrees, here would be 180 degrees, 270, 360 degrees, right? It has nothing to do with how big the circle is. I could also make a gigantic circle right in the same space and spin my pen around, and it would still be 360 degrees. Okay? Now, radians, what they did was they took this angular measure. So just like this could be measured in feet or miles or inches, angles can be measured either in these degrees or they can be measured in radians. So another way that we can describe this spin around is 2 pi radians. So that doesn't describe how long the string would be if I were to put a string on this, like not the circumference, but how much did I spin? So one full spin around this circle is 2 pi radians. And the reason why they use 2 pi radians is they wanted it to be related to the circumference. So they said, well, if the circumference is going to be 2 pi feet, why don't we make one spin around be 2 pi radians? Or if it's going to be 2 pi miles, why don't we make it 2 pi radians? So this makes it kind of easy to work with, right? So this is not really related to their circumference in like a very clear way, right? They're not really related, but these two are very related. So if I know something about their circumference, I know something about, the angle measure, they're related in a lot of good ways that help us, okay? So let's take a look at this. So we know that 360 degrees is the same as saying 2 pi radians. And you can say rads, or if there's no, so this is the symbol for degrees. If you don't write anything, it implies radians. So I could actually write that and it would still be accurate, because that's, radians is implied if you don't say anything else. Okay, so one spin around, they're the same. Now, if I spin halfway around a circle, so from here to here, hopefully people would understand that halfway around the circle would be 180 degrees. Well, if I spin halfway around something that is 2 pi radians and I only spin to here, well, how many radians would that be? Hopefully you can, imagine that that's pi radians. So again, another way to think about it is just cut each of these in half. If I cut this in half and this in half, then it should be the same thing, right? Doing the same thing to both sides of the equation. So 180 degrees should be equal to pi radians. Make sense? Okay, later on you're going to see why these are superior. I know everybody hates them at first because there's a pi in them, and I don't know why people get thrown off by it, but these are actually much smaller numbers already that we're dealing with. This is a 1 and a 2, right? This is 180, 360. These are much easier. All right, so let's take a look at this now. If I only go a quarter of the circle, everybody can see that this is 90 degrees. Well, here, I'm going to go a quarter of the circle, or it's easier to think about it as half of the half a circle. Well, half of the circle was pi, so half of the half of pi, right, is going to be pi divided by 2. And that's what we just say. We divide it by 2. So here we can see that 90 degrees is equal to pi over 2 radians. So one easy way to kind of do the next one is, well, from here to here, hopefully everybody knows 3/4 around. So 3/4, if you multiply 360 by 3/4, you get 270. That's how we would work with that. We actually have to, multiply or do whatever, break this into 4 pieces and take 3 of them, whatever you do to get that. So it's kind of annoying math if you don't know it right off the top of your head. But this one is actually very easy. So I'm here at pi, and I'm going to go to get down to here, I'm going to go another one of these little segments. Well, that segment is pi over 2, isn't it? So if this spin is pi over 2 and this is pi, this is the same thing as 2 pi over 2, right? That's the same thing as 1 pi, 2 pi over 2. So you have 2 pi over 2 and another pi over 2. That means that this one is 3 pi over 2. So that math is actually a lot easier than, doing whatever you have to do to figure this one out if you didn't know it. Okay, so from here to here is 3 pi over 2. So 270 degrees is equal to 3 pi over 2. Now you really don't have to memorize these, but knowing these 4 things is good, and knowing these 4 things is good because it's going to help you to do the other ones. Now if we want to convert degrees to radians, there's a couple ways we can do it, but there's a few angles that we use all the time that it's just good to know their radian measures because it's helpful. So let's just take the top of this circle for a minute. Okay, so this is pi, or some people call it 180 degrees if I spin, in spin, right, from here. So not a distance, but how much my pen spins. Okay, that's 180 degrees. So it's like turning around backwards if you're standing up and you turn around backwards. All right, so let's take this and cut it into 3 equal pieces. So if I take 180 and cut it into 3 pieces, hopefully, you know right away that 180 divided by 3 would be 60. So this spin would be 60 degrees. And of course, if I cut this into 3, so I only do a third of it, well, how do I cut that in 3? The same way I cut it in half, I'm just going to write it as pi over 3. And so now you can see that pi over 3 is the same as 60 degrees. Pretty easy, right? Let's take that same idea, and instead of cutting it into, our nice 3 pieces, let's cut it into 6 even pieces. So what happens when I cut 180 into 6 pieces? Well, now each of those is 30 degrees. And if I cut this into 6 pieces, well, how many pieces would I have? Each piece would be, not how many pieces would I have, I'd have 6. How much would what would be the angular size of each piece? It would be pi divided by 6. You cut it into 6 pieces. So 30 degrees is pi over 6. And the last very common one that, you really need to probably have some understanding pretty quickly of what it is if I cut this one in half, everybody knows that this one is pi over 2 or 90 degrees. So from here to here. is pi over 2 or 90 degrees. But if I cut each of these in half, well, half of 90 degrees is going to be 45 degrees. Or if I cut this in half, or you can think about it as cutting this into 4, this is going to be pi over 4. Okay? So these are some basic ones that you're going to be using all the time, and they're related to those special triangles that we use all the time. So these angles, it's very, helpful if you kind of just know in your head that you've seen them, that you know what these are. When you see pi over 3, that you just recognize what angle you're talking about. Now it gets to the point where hopefully you actually aren't even thinking about the degrees. You're only thinking about radians, because that when you get to there, then it actually makes it a lot easier when you can just kind of read the radians and be okay with that. Okay, so if it's not one of these special ones, what can we do? Well, one way we can do it is take these ideas here, take these equations here, okay? So one thing that we might want to do is say how these two are the same, okay? We usually use this one just because it's easy, because this is 1 radian. You could use any of these relationships to do it, but we usually use this one. And we think of 180 degrees is the same as pi radians. So I made a proportion. I'm comparing the degrees to the radians. And this is a fraction that's equal to 1. Do you see that? They're equal to each other. So when you put something, this is equal to 1. 1 degree radian. I know, whatever that would be. But it's equal to 1. Do you see how that's equal to 1? So here's what we would do. If we're trying to figure out some radian measure or some degree measure, but we don't know, what it is in the other one, we're going to use a proportion. So I'm going to say 180 degrees over pi. Since these two are the same, I want to make a fraction over here that's equal to the same thing. So let's say we had 50 degrees, and I want to know how many radians it is. If I put a 50 up here, and I want this fraction to also be equal to 1, right? So that when they divide, there's the same amount of degree on top, or the same amount of angle measure on top as on bottom. This is the thing that we would solve, right? So you'd have 180 degrees times, I used a question mark, but you can use whatever you want, is equal to 50 pi. You could just use an X or whatever. And of course, these are degrees and these are radians. So I'm going to write them just so that we know. All right, now I want to know what this little question mark is. So I'm going to divide both sides by 180. All right. So what happens over here is, well, of course, the degrees cancel out. Do you see how you're dividing degree by degree? These cancel out. So the question mark is equal to 5 pi over 18 radians. And that's what this is. So 50 degrees is equal to 5 pi over 18. Okay, so you just make a little proportion. And can I use any one of these? Sure, it doesn't matter which one you use to make your proportion, but usually this one's easier because you're multiplying by 1, right? And if I knew the radians and needed to find the degrees, what could I do? I'm going to use that same ratio. Could I flip it upside down? Of course, as long as the degrees are either both on top or both on bottom, because that's, how proportionality works. It doesn't matter which way you put it, as long as the same things that you're measuring are in the same place, or the same units are in the same place. So if I had 3 pi over 8, let's say, and I wanted to know how many degrees, this is what I wanted to know, I would do I'm just going to leave the thing just as it is. I'm not even going to bother to flip it upside down. You can if you would like. I'm going to set that equal to X over 3 pi over 8 radians. And this time, when you multiply, so let me just get another little piece of paper because I'm out of space. It's getting kind of small. So it's going to be 180 times 3 pi over 8. When I multiply these together, this is degrees and this is radians, is equal to X pi radians. Okay, So over here, let's simplify this a little bit. So if I divide by 8, I can at least reduce it, I guess, right? I can reduce it a little bit. Or what's 180 times 3? I guess let's just do that. Let's do 540 over 8. So 540 pi over 8 radians. Then I'm going to divide both sides by pi radians, and I'll simplify it all at the end, or reduce at the end, I guess. So now these pi's cancel out. And so I'm left with degrees. Can you see that? And again, these pi's do not mean radians. That's not the unit for radians. That's actually the pi, 3.14. It's a number. So radians don't have to have a pi in them. And degrees can have a pi in them. They just usually don't. Okay, so for me, what I would do is I would reduce this fraction. I wouldn't write it as a decimal because I don't really like decimals. So you could divide them both by 4, I guess. So that would be a 2, and that would be a 135. So this is 135 over 2 degrees is equal to x. If you wanted it as a fraction, that would be 67.5. Okay, so I would, I'm okay with that. You can write it as a decimal if you want. Doesn't really matter. Okay, so you're just using this little idea of 2 things that are the same to figure out 2 other things that are the same by using proportionality when you're converting. And where do radians come from? They come from this idea where they thought, why don't we make the radian measure or the angle measure come out to be the same number value as that spin around a 1 unit circle. We call this a 1 unit circle or a unit circle. All right, so we'll talk about unit circle more in other videos. But there you have it, a little brief introduction to degrees and radians.